important pathway of exposure to lead. Proper measurement of dust lead levels is therefore essential to the risk assessment process. This videotape demonstrates wipe sampling, the recommended method of dust sampling for most routine risk assessments. Wipe samples for settled dust can be collected from floors, both carpeted and uncarpeted, interior windowsills and window troughs, and other reasonably smooth surfaces such as stair treads. In most cases, samples should come from areas where child contact is highest, such as play areas, or the floor inside doors where foot traffic is heaviest, and from windowsills or window troughs, preferably from the most commonly used window in a room. Single surface sampling will be demonstrated here. Your instructor can describe how this method should be modified for composite sampling. You will need to take several tools with you to the site. Let's look at these one at a time, beginning with disposable wipes. White media should be sufficiently durable so that they are not easily torn, but nevertheless can be easily digested in the laboratory. Examples of acceptable white media are included in your student manual. You'll also need non-sterilized, non-powdered disposable gloves, non-sterilized 50 milliliter plastic or polyethylene centrifuge tubes, pre-printed container labels, or a permanent ink felt tip pen, reusable templates, or masking tape to mark the sampling location, a ruler or tape measure, plastic garbage bags, and a field sampling form. The first step in the dust wipe sampling procedure is to identify the exact area to be wiped. On floors, the area is usually a play area, or just inside the main entryway to the room or under a window. For windows, the area is on either the interior sill or trough of the most commonly opened window. Do not walk on or touch this area. Fasten either the template or the masking tape to the perimeter of the area in a rectangle or square about 1 square foot in area. The area does not need to be exactly 1 square foot, but you will have to measure it exactly after taking the sample. If the area has a lot of debris or dirt, reduce the sample area. Remember, since you will measure the area sampled, the area need not be exactly 1 square foot. Reducing the area will enable you to better collect all material that's within the defined wipe area. For interior windowsills and window troughs, this step is performed in a similar way. Remove all large visible debris. Do not touch the test area yet. Fasten 2 strips of masking tape across the sill or trough to define an area of at least 1/10 of a square foot, or at least 4 inches by 4 inches. The area should be as large as possible, while at the same time allowing you to collect all material in the wipe area. Because of the amount of dust and debris at this location, only half of this trough will be sampled. Dispose of the top disposable wipe to ensure that the wipes are still moist. Do not use wipes that have dried out. Now, examine the centrifuge tube you'll be using. Partially unscrew the cap to be sure it can be opened. The cap should not be placed on the floor. To start, put on a single new glove or a pair of new gloves, depending on your preference. Do not touch anything other than the wipe with your gloved hand. With your gloved hand, remove a wipe from the dispenser and shake it open. Grasp the wipe between your thumb and your palm. Place it flat on one corner of the wipe area and wipe the entire surface from side to side with S-like motions. Do not leave the boundaries of the tape or template. Be firm but gentle. Too much pressure will cause the wipe to curl. Too little pressure will result in poor dust collection. Use as many S motions as you need to fully cover the area. Your second pass will be in S-like motions from top to bottom. Lay the wipe on the test area, contaminated side up, and fold the wipe in half so that the contaminated side faces inward. Do not touch the contaminated side. Place the wipe in the top corner of the wipe area and wipe the entire surface from top to bottom with S-like motions. Again, do not leave the boundaries of the tape or template and remove all visible dust, debris, and paint chips in the wipe area. In a narrow strip, like a window trough, your second pass will duplicate the first. Wipe the entire surface from side to side with S-like motions if possible. To package the wipe, fold the contaminated side inward once again. Insert the wipe into a centrifuge tube without touching anything else. Get as much of the debris and paint chips onto the wipe as possible, but do not pick up debris with fingers or tweezers. Seal the centrifuge tube by closing it firmly. It is not necessary to tape the lid. Label the tube and put the sample number from the laboratory submittal form on the label and on the field sampling form. Each sample number must be unique. Also on the field sampling form, record the name of the room, surface type, and surface condition. Before you remove the tape or template, don't forget to measure the wipe area. Use a tape measure or ruler to measure the wipe area to the nearest eighth of an inch. Record the measurements of the area on the field sampling form. Remove and dispose of all masking tape, gloves, and other debris in your trash bag. If you are doing more sampling, you must change your gloves for each sample. When you are done, you must remove all of your trash from the premises. Do not use the residence trash cans. Once a day or every 50 samples, whichever happens more frequently, create a field blank by removing a wipe from the container. Remove the wipe with a gloved hand, refold it, and insert it into the tube without touching any surface. Label it so the lab is blind to the blank, but your records should identify it clearly. Soil samples are typically collected using a method called core sampling. Core sampling is the preferred method because it allows you to collect a consistent sample from site to site. The alternative method of sampling, collection of soil with a scoop, should only be used if the soil is too sandy or friable to collect a core sample. Core sampling will be demonstrated here. For routine risk assessments, composite soil samples should be collected. Each composite sample usually consists of 3 to 10 subsamples mixed together in the same container. These are the tools you will need for performing soil core sampling. First, you'll need a core sampling device, such as a professional soil probe or a 5 cc disposable syringe with the end cut off. You'll also need disposable wipes to clean your tools. Next, you'll need these unsterilized and unpowdered disposable gloves. For storing the samples, you'll need non-sterilized Ziploc plastic bags. These can be industrial strength, 4 mil thick bags, or consumer type bags. If you use the consumer type bags, you must double bag. You'll also need pre-printed labels or a permanent ink felt tip pen to mark the sample bags and laboratory submittal forms. For cleanup, you must bring along your own trash bags or other receptacle. Finally, you should have both a notepad to complete a sketch of the property and a field sampling form for soil to record sample numbers and results. Before collecting soil samples, prepare a property sketch showing the lot boundaries and the rough position of the buildings. This sketch will be used to record the sampling locations. In most situations, 2 composite samples per dwelling will be adequate. One from a play area, the other from around the building foundation. The sampling procedure begins by determining the locations where the core samples will be taken. Start with the area around the perimeter of the building. You will be collecting between 3 and 10 subsamples from all sides of the structure where bare soil is present. Look for bare patches of soil near the foundation of the structure. Allow about 2 to 6 feet between each subsample. Mark the subsample locations on the property sketch. After the perimeter sites are identified, find the children's principal play area. Here, you will collect between 3 and 10 subsamples of soil along an X-shaped grid. Again, look for areas where the soil is bare. Allow about 2 feet between each subsample. As you identify and mark the sites, record them on the property sketch. Take core samples from the top 1/2 inch at each location that you've selected and place it in a Ziploc bag. Use a separate bag for each composite sample, but not for each sub-sample. If you see paint chips in the sample, do not attempt to remove them. Try not to include twigs, stones, grass, and other debris. Remember to double bag unless you're using a 4 mil thick bag. Use a pre-printed label or record the sample number on a label and affix it to the bag. Record the sample number on the field sampling form. When you've completed all of the sampling, clean the core sampler with a disposable wipe, or if you're using a syringe, dispose of it. You do not have to clean the core sampler after each subsample is collected. However, it should be cleaned after each composite sample has been completed. Remember, bag all trash and remove it from the property for disposal. Paint chip sampling is one method of testing deteriorated paint. In most cases, risk assessments will result in a need to measure 2 to 10 painted locations. If more samples are necessary, you should suggest that the owner have a complete paint inspection conducted. Paint chip sampling is a destructive method that may release a small amount of lead dust into the dwelling. You should perform dust and soil sampling before chip sampling to minimize the possibility of cross-sample contamination. Even though samples are collected from inconspicuous areas, residents should always be notified when chip samples are needed. Single surface sampling will be demonstrated here. Your instructor can describe how this method should be modified for composite sampling. Let's look at the tools you'll need to assemble for paint chip sampling. You'll need a sharp stainless steel paint scraper and disposable wipes to clean the scraper. You'll also need several pairs of non-sterilized, non-powdered disposable gloves, a ladder, a ruler or tape measure, and a roll of plastic sheeting. A heat gun is recommended to soften the paint. The type of container you use to send the chip sample to the laboratory depends on the way the results will be reported. If the results are to be reported in milligrams per square centimeter, use hard-shelled containers that can be rinsed quantitatively to prevent sample loss. If the results are to be reported in parts per million or percent by weight, plastic bags can be used because it's not necessary for the lab to analyze the entire sample. You should also have a supply of pre-printed labels for the samples or a permanent felt tip marker. Finally, you'll need a field sampling form and a laboratory submittal form. The sampling procedure begins with the selection of an inconspicuous spot on the surface to be sampled. The recommended area of a sample chip is about 4 square inches. You will need to set up some kind of containment to prevent paint dust from spreading, usually a piece of plastic sheeting under the area to be sampled. Now you're ready to put on the disposable gloves and take the chip sample. You may use a heat gun to soften the paint before removal and to help you scrape off only the paint and not the substrate. Attempt to remove all the paint, but none of the substrate. If sample results will be reported in milligrams per square centimeter, before scraping, you must measure the sample area exactly using a ruler and score the area with a razor-sharp edge. When using a heat gun, be careful to apply only enough heat to soften the paint without making the paint smoke or char. Remove all of the layers of paint within that area and place the entire sample in a hard-shelled container. Attempt to remove all paint within the sample area. You must identify the sample with the sample number on the label. Record the sample number on a laboratory submittal form. Finally, record the sample number, the room location, and the component on the field sampling form. For samples that were measured exactly, record the dimensions and area of the sample in centimeters. Once the sample is in its container and the paperwork is done, you can clean up the containment and repair the surface. Use disposable wipes to clean up tools and dust, and place these in the trash bag. If the owner requests, repair the surface with spackling and/or new paint. When you've finished all work, remove all your trash bags from the premises. Wash your hands thoroughly with soap and water. Try to obtain permission from the owner or resident to use their bathroom. If no running water is available, use the disposable wipes. The final product of the risk assessment is a report containing a workable lead-based paint hazard control plan. The plan should include a list of the lead hazards found in the dwelling unit, if any, and the options that can be used to control these hazards for that specific property. In order to carry out this function of the risk assessor's job, you should be familiar with the lead hazard control process and the types of control options that are available. There are 4 critical steps to any lead hazard control work: worksite preparation, hazard control, cleanup, and clearance. Lead hazard control methods generate varying amounts of leaded dust, paint chips, and other lead-contaminated materials. Each of the 4 steps must be conducted with the necessary precautions to protect residents, workers, and the environment. Some lead hazard control work requires complete isolation of the work area and/or full evacuation of the residents and their belongings, while other methods require little or no containment. Containment refers to various methods of preventing leaded dust from migrating beyond the work area. Containment ranges from the simple use of small disposable plastic drop cloths immediately underneath the work area to the sealing of doors, windows, and duct openings with plastic sheeting. Chapter 8 of the HUD Guidelines offers specific guidance about the proper level of worksite preparation for a particular job. As one example of proper worksite preparation, a contractor should conduct the following activities before beginning paint removal or component replacement work. Residents, particularly young children and pregnant women, should be moved to a lead-safe area and should not enter the work area at any time during the work. Furniture, carpeting, and other belongings should be removed or sealed in plastic sheeting so that they do not become contaminated with lead dust. Floors, especially older wooden ones, are extremely difficult to clean. Therefore, they should be covered with at least 2 layers of plastic sheeting 6 mils thick. By layering the plastic, the top layer may be damaged and repaired without exposing the floor to dust and debris. The base layer should not be removed until just before the final cleanup. The edges of all layers should be sealed at the walls with tape. The areas not involved in abatement should be isolated from those that are by sealing the connecting doorways with plastic sheeting and securing it at the edges. To the extent possible, windows should be kept closed during abatements. In cases where windows are missing or are removed as part of the abatement, seal the openings with plastic. If sealing from the inside is not possible, install plastic on the outside. If exterior abatement will be conducted, the area immediately beneath the work surfaces should be protected with plastic. Plastic sheeting should be extended 10 feet from the wall and should be weighted down so that it does not blow in the wind. Exterior plastic should not be left down overnight or during inclement weather. Once the work site is prepared, the dwelling unit is ready for the hazard control work to begin. There are two main categories of lead hazard control: interim controls and abatement. Interim controls are generally short-term measures to control lead-based paint hazards. Interim control measures include paint film stabilization, friction and impact reduction treatments, and dust removal. Dust removal involves the same techniques that are used during cleanup of all lead hazard control work. These techniques will be demonstrated later in this video. Paint film stabilization involves the essential elements of residential painting. These elements include the repair of substrates and any sources of moisture, followed by proper surface preparation and paint selection. The keys to proper surface preparation include removal of all loose paint by hand scraping or sanding the surface after it has been misted with water, reduction of any surface gloss by wet sanding or chemical etching, removal of all surface contaminants by cleaning with detergents or trisodium phosphate and then water. Once the surface is prepared, the surface should be coated with a primer and a top coat. The coatings should be appropriate for the surface to which they will be applied and the conditions which they will endure. As an interim measure, some owners will decide to treat the friction and impact points of a component instead of treating the whole component. Possible friction and impact reduction treatments include installing window channels or slides, wrapping or capping of window sills and troughs, planing and rehanging doors, installing rubber tread guards, and adding molding to walls and baseboards. Abatement involves lead hazard control treatments that are designed to last at least 20 years. A contractor certified in lead abatement is required when abatement is conducted. Abatement measures include building component replacement, enclosure, paint removal with chemical or contained abrasive, and encapsulation. The most desirable abatement method is probably building component replacement because it offers a permanent solution to a lead-based paint problem with minimal dust generation. Components that can be replaced include doors, windows, trim, porch and stair railings, and other removable components such as cabinets. The process starts with the careful removal of the selected components in a way that minimizes the generation of dust and debris. Lightly mist the component and then carefully remove it. Care should also be taken not to damage the surface from which the component is being removed, because this will add to the project's cost for repair work. Once removed, the components should be wrapped in 6mm plastic and sealed with tape. Wrapping the components this way minimizes the chance of environmental contamination at the work site and during transportation. The waste should be tested to determine if it is hazardous prior to transport and disposal. Replacement components should then be installed in accordance with standard construction practices. Enclosure is the installation of a rigid, durable barrier that is mechanically attached to a building component. Components such as walls, ceilings, trim, and floors that are coated with lead-based paint are potential candidates for enclosure. For example, walls and ceilings that have deteriorated lead paint can be enclosed by attaching 1/2-inch drywall to them. The drywall should be glued, screwed, and finished through standard construction practices. All edges and seams should be sealed with caulk or other sealant. Enclosures are intended to prevent access and exposure to lead-based painted surfaces and provide a dust-tight system to trap any lead-contaminated dust. In cases where contaminated wood is of architectural value, it can be treated by off-site paint removal. Off-site paint removal involves the removal of the component, off-site stripping by a commercial paint stripper, and reinstallation. Components that are likely candidates for this treatment include doors, windows, trim, and other removable components such as decorative stair railings. The process begins with the careful removal of the selected components. Once removed, the component should be wrapped and sealed in 6mm plastic for transport to a commercial paint stripper. The components should then be stripped using standard industry practices. Care should be taken that the treated surfaces have been neutralized and dried before being released from the paint stripper. Treated components are then reinstalled in accordance with standard construction practices. Components that cannot be removed may be treated in place with chemical paint strippers or a heat gun. Open flame burning, however, should never be used because this process produces toxic fumes. Strippers containing methylene chloride are not recommended and are prohibited in a number of locales because methylene chloride can cause liver and kidney damage, carbon monoxide poisoning, and is suspected to cause cancer. One on-site chemical stripping process is the application of a caustic paste mixture. Workers are required to wear safety goggles and long neoprene nitrile or rubber gloves during this application process to protect themselves from chemical burns. An eye wash is also required in the abatement area in case the paste contacts the worker's eyes. Caustic paste should be applied according to the manufacturer's specifications. Surfaces are covered entirely, and the paste must be worked into all cracks and crevices to assure a thorough job. After application, cover the paste with a polyethylene or paper blanket according to the manufacturer's instructions. The blanket helps keep the paste moist for best results. After waiting the prescribed amount of time, usually 24 hours, the blanket and paste are removed using a scraper, spatula, or putty knife. Care should be taken to remove the blanket, paste, and paint intact if possible. Be sure to scrape any residual paste or paint left on the surface promptly. All scraping needs to be done while the surface is still moist to avoid dust generation. The stripped surface is then thoroughly washed down with solution. The solution usually contains an acid. The solution neutralizes the surface and prepares it for repainting. After the surface is neutralized, it should be scrubbed with a detergent followed by water to remove remaining lead residue. If the washing process is not thorough, new paint applied to the surface will begin to deteriorate within a few days or weeks. Retrieve the wastewater through wet-dry vacuuming or sponging. This liquid waste contains significant amounts of lead and may need to be tested and treated as a hazardous waste. The solid debris from this entire process is almost always hazardous waste and should be deposited in a watertight and corrosion-proof container and transported to an appropriate waste facility. Lead-based paint may also be removed on-site using a heat gun. This process consists of applying heated air to the painted surfaces with a portable hairdryer-like instrument. The heat softens the paint so it can be removed by scraping. Since the paint is soft and no longer brittle, scraping does not tend to create additional dust. A word of caution: the high setting on some brands of heat guns is hot enough to volatilize the lead in the paint, thereby releasing dangerous fumes. The setting of the heat gun should be fixed so that its temperature does not exceed 1100 degrees Fahrenheit. When the heat gun is used extensively, air monitoring is suggested. Additionally, the heat gun should only be used in well-ventilated spaces, and its operator should wear a respirator and protective clothing. The scraped paint is a likely hazardous waste and should be transported and disposed of with care. Paint may also be removed by mechanical means, such as HEPA sanders, HEPA abrasive blasters, or HEPA needle guns. Here, a vacuum blaster is shown as an effective and safe technique for exterior residential abatement use. The paint is blasted off with an abrasive. The dust is captured by the shroud and the vacuum. A choice of blasting media is available. Vacuum blasting is appropriate for metal, brick, concrete, and other hard surfaces. To be effective, the blast head must remain in continuous contact with the surface. As with any of these processes, air monitoring and testing on your particular application may be required by OSHA if an initial exposure determination has not been made. Encapsulation is a process that makes lead-based paint inaccessible by providing a barrier between the lead-based paint and the environment. The barrier is formed using a liquid-applied coating with or without reinforcement materials or an adhesively bonded covering material. Unlike enclosures that are mechanically fastened to the underlying structure, encapsulants are primarily attached to the surface through adhesion to the existing paint film. Encapsulants will only control hazards if the bonds between the encapsulant and the paint and the substrate are secure. The success of an encapsulation application depends on the proper assessment of the suitability of the encapsulant for a particular substrate and proper surface preparation and application procedures. Massachusetts was one of the first states to develop regulations that outline the steps to take to determine the suitability of applying a particular encapsulant as a lead hazard control treatment. The following guidance summarizes the suitability tests required in Massachusetts. 2 simple tests determine whether the use of an encapsulant is appropriate. These tests are the tape test and the patch test. The tape test is a 3-step process. First, visually examine the surface to be treated. If the surface coat demonstrates significant deterioration, encapsulation should not be considered as a viable treatment. If the surface is visually intact, proceed to the next step, the initial tape test. First, clean and dry the surface so the tape will adhere to it. Next, cut a 3-inch piece of 2-inch wide clear tape. You want to fold over the top of the tape and then apply it to the surface. The tape should be applied evenly and smoothly. Using the end of a pencil, rub the tape onto the surface. After waiting about 90 seconds, remove the tape. If 1/16 of an inch or less of paint is attached to the tape, continue on to the final step. The final step of the tape test is the X-cut tape test. Again, clean and dry the surface so that the tape will adhere to it. Using a sharp utility knife and a straight edge, cut an X on the surface. The cuts should be at least 1/2 of an inch long and should go down to the substrate. After the X is cut, take a 3-inch piece of the clear tape, fold over the top, and apply it over the X. Once again, use the end of a pencil to rub the tape onto the surface. After 90 seconds, pull the tape straight down from the surface. If 1/16 of an inch or less of paint is attached to the tape, the surface may be encapsulated. Many different encapsulation products or systems are now on the market. Before purchasing an encapsulant, check to see if the federal government or your state regulates its use. At least one state, Massachusetts, has standards for encapsulants in place and maintains a list of approved encapsulants. Once the decision has been made to proceed with encapsulation, the entire surface of the component must be cleaned and dried. Then the encapsulant selected for this job should be applied to a small area. This is called a patch test. A patch test should be conducted on representative samples of each architectural system that will be encapsulated. For example, if plaster walls and wooden trim will be encapsulated throughout the unit, a patch test on each component should be conducted. Begin the patch test by applying the encapsulant to a 36 square inch area. Usually this will be a 6 by 6 inch square. After the encapsulant is applied, use a gauge to confirm that it meets the manufacturer's recommended thickness. Allow the encapsulant to fully dry and cure. Once the encapsulant is dry, visually inspect it to make sure that there are no signs of blistering or cracking. Next, using a sharp utility knife and a straight edge, make a 1.5 inch X cut into the patch down to the substrate. Put a 3-inch piece of pressure-sensitive tape over the X and rub it into place with the end of a pencil. After about 90 seconds, remove the tape. If more than 1/2 inch of the encapsulant lifts or peels off, the encapsulant is not appropriate for the surface. As a final step of the patch test, use the utility knife to probe the edges of the patch. Again, if more than 1/2 inch of the encapsulant lifts off, the encapsulant is not appropriate. All lead hazard control activities can produce dangerous quantities of leaded dust. Unless this dust is properly removed, a dwelling unit may be more hazardous after work is completed than it was originally. Throughout the project, periodic cleaning should occur and debris should be carefully removed from the premises. Contaminated bulk debris, such as doors, windows, and baseboards, should be removed from the job site on a daily basis. This debris is first wrapped in 6mm plastic, then sealed. Smaller, sweepable debris should also be removed on a daily basis. Before sweeping, lightly spray the area with water to keep the dust down. The swept debris is double-bagged and sealed. All materials should typically be tested to determine if they are hazardous waste in order to arrange appropriate transport and disposal. Chapter 10 of the HUD Guidelines offers additional advice on waste disposal. A final cleaning should be conducted after all abatement and interim control activities. Final cleaning begins with the removal of all plastic sheeting from the work area. Lightly wet the entire surface of the plastic with a water spray to minimize dust. Then carefully unseal and fold the edges to the middle to trap dust or dirt. After the plastic has been folded to a manageable size, insert it into a plastic bag and seal it for removal to an appropriate landfill. Plastic covering doors, windows, cabinets, and appliances should be removed, folded, and disposed of first, followed by the plastic on the floors. After all protective plastic has been carefully removed and disposed of, and all other materials removed from the premises, clean the entire area using a HEPA vacuum, wet wash, HEPA cycle. First, the entire work area should be thoroughly HEPA vacuumed, starting with the ceiling and working down to the floor. Wet wash these areas with a solution containing a high phosphate detergent, such as trisodium phosphate, a lead-specific detergent, or other effective cleaning agent. Follow manufacturer's instructions when preparing the solution. The solution should be changed often during the wet wash process, and the wastewater should be retained for testing and treatment as a possible hazardous waste. Consult with your local water and sewer utility for directions on proper disposal. After the wet wash process, the entire property gets a thorough HEPA vacuuming once again. Before clearance, all treated surfaces should be sealed so that their surfaces are smooth and cleanable. For example, newly replaced woodwork and repaired wall and ceiling surfaces should be primed and repainted. For best results on problem areas such as window sills and wells, a finish coat of enamel is recommended. Wooden floors should be either sealed with a deck enamel if previously painted, or a clear urethane sealant if not painted. If the floors are badly deteriorated, cracked, splintered, or have several gaps, it is necessary to take additional measures, such as laying new subflooring or covering them with tile or linoleum in order to assure that dust trapped within the cracks is not reintroduced into the environment. Tile and linoleum floors should be sealed through an application of common household floor wax. Concrete floors should be sealed with an appropriate sealant or paint. Clearance is required as the final step in all abatement projects and is recommended at the conclusion of interim controls. Clearance has three purposes: to ensure that the lead hazard control work is complete, to detect the presence of lead dust, and to make sure that all treated surfaces have been repainted or otherwise sealed. The final clearance evaluation must be performed by a certified inspector or risk assessor. It should take place at least 1 hour after the final cleaning to allow airborne dust to settle. The clearance evaluation includes a visual examination of the entire work area and dust sampling of certain components, such as floors, window sills, and window troughs. You should be familiar with the federal clearance standards and any local standards that are in effect in your area. Should a dwelling unit fail the clearance tests, additional cleaning and possibly some work may be necessary. Once the dwelling unit passes clearance, the lead hazard control work is complete and the residents and their belongings may re-enter the work area.